Hello and welcome. In this video, we're going to be continuing our series where we solve tough questions and unusual ideas from the International A-Level Edexcel Mechanics 1 course. So let's try attempting this question. So let's read first. We have a uniform wooden beam. So from the word uniform, I know that the mass acts or the weight is distributed evenly. So the mass of the rod or the beam is distributed evenly. So that means that the weight acts exactly in the middle of the beam. If it was not uniform, maybe this part is heavier than this part, so the weight force is going to shift a little bit to the left. However, this is not our case. Our case is a very nice uniform wooden beam of mass 20 kilograms. So I know that this is 20 G and length 4. So the whole length is 4. That means that from here to my weight, it's around 2 meters. It rests in equilibrium, so we know two things. We know that the sum of forces in opposite directions are 0, or forces in opposite directions are equal, and we know that moments, anti-clockwise moments and clockwise moments about any point on the beam are also equal. So it says that it sits horizontally and on two supports, C and D. So that means that we have a reaction here called RC, let's call it RC, and a reaction here called RD. One support is at C where AC is 1.6 meters, and the other support is D where DB is 0.4 meters. A boy of mass 60 kilograms stands on the beam at the point P. So this is a point P. We know that this boy has a weight of 60 G, and stand where AP is 3 meters, so the distance from A to P is 3 meters, and the beam remains in equilibrium in a horizontal position. It says by modeling the boy as a particle and the beam as a uniform rod, find AI in terms of G, the magnitude of the force exerted on the beam by the support at C. So we want to find the reaction force at C. So the magnitude of the force exerted on the beam by the support. So it's the reaction force from the support on the beam. So we can do this by, let's say we want to take moments about a point. Let's take moments about D. And why did I choose D? Because in the first question, I want to find the reaction C. So I would take moments about point D so that my RD now cancels, or it will not be in my equations, as the distance, the perpendicular distance between RD and the point D is basically 0 because they're both at the same point. So let's start. So let's say that moments in one direction equal the moments in other direction. So let's start by this 60G. So if this is 3 meters and from here to D is basically 4 meters, the whole thing minus 0.4, so 3.6 meters. And I know that this is 3.6 meters, and from here to P is 3 meters. It means that from P to RD is basically 0.6 meters. So I will have a 60G times 0.6. This is going to give me a moment in this direction. The 20G is also going to be in the same direction. So plus, I know that from the weight of the beam to point B is 2 meters. So 2 minus 0.4, that is going to give me a 1.6 meter distance. So it's going to be 20G times 1.6. And then I have an RC. However, it points upwards, so I can see that the moment produced now is no longer in the anti-clockwise direction. However, it's in the opposite direction. So it's going to be on the other side of the equation, and I will have it as RC multiply the distance between RC and RD is, so if from A to D is 3.6 and A to C is 1.6, so basically RC to RD is a distance of 2 meters apart. So from here I can find RC as 60 G times 0.6 plus 20 times 1.6 G. So this is basically these two are 68 G, and then I had a 2 here, so if I divide both things by 2 is going to give me an RC of 34G. Okay, and for part double I can find the reaction at D using the idea that forces in different directions are going to be equal. So I know that the upward forces are going to be equal to the downward forces. So I know that RC plus RD, so RC, which is 34G, plus RD, they're supposed to equal the downward forces, which is 20G plus 60G. So if I want to solve for RD, I'm going to have RD equals 20G plus 60G is basically 80G minus 34G. This 34 moving to the other side. So RD equals 80 minus 30, that is 50, minus another 4, that is 46G newtons. And I don't forget my unit. Okay, so the difficult part is here when it says that the boy starts to walk slowly along the beam towards the end A. So now we know that any change in any forces will alter my reaction forces. So for part B, my reaction forces that I calculated are no longer the same. Okay, the only thing that will stay the same is the weight of the beam, and it's going to stay exactly 20G and 2 meters apart, 2 meters from the end A. So the boy starts walking in this direction, okay? Find the greatest distance he can walk from P without the beam tilting. So basically, we want to keep the boy walking to the left, and we want to see what is the maximum distance he can walk and the beam wouldn't start to tilt. So let's think what's going to happen. So I have my beam and it's supported here at C and at D. So whenever the boy is between C and D, nothing is going to happen. No tilting is going to happen, right? However, if my boy, let's say, is here, then this can cause tilting in this direction. You will find the beam tilting like this, right? And also, similarly, if the boy, which is our case here, starts moving to the left, if he passes C, okay, what's going to happen? The beam might tilt in this direction, correct? So this is basically what's going to happen. So we want to find, let's say this is the point he moved to, okay? So he moved this distance, okay? So his weight is now acting here. His weight was 60G, okay? And let's think about what's going to happen when the beam is about to tilt. So when the beam is about to tilt, we know that it's going to tilt this way, right? So it's going to somehow kind of lift off D. And if there is something that is lifting off D, will I have any reaction force at D? No, because a reaction force is when something is pressing on the support, so the beam is pressing on the support down, so the support is pressing back up, which is from Newton's third law. However, if the beam is about to move or to tilt, so it's about lifting, it's not touching, it's touching, but it's not exerting any force on the support, thus R at that point is going to equal 0. So we know when the beam is about to tilt, okay, then the reaction at D is going to equal to 0. And as the boy moves further to the left, the beam tends to tilt more, okay? So the greatest distance he can walk from P will be the distance where the beam is about to tilt, okay? So let's see how we can do that. Let's just erase a little bit. So we know all these things. We know that RD is going to equal to 0. We will have an RC over here. And then let's say we're going to take moments about C. Let's say we can take moments about C. Okay, so if we take moments about C, this is a clever way to cancel the reaction at C because I don't know it. I can find it, okay? The reaction at C is going to basically equal the two downwards forces, so it's going to equal 20G plus 60G, which is 80G, okay? However, I want to take moments at C to try and solve this question. So let's say, okay, moments at C. Let's name the distance between this boy and C. Let's name it a distance X. Okay. So now we will have two forces acting in different direction. The boy is going to exert a moment in this direction, and the 20G is going to, which is the weight of the beam, is going to exert a moment on the opposite direction. So first of all, let's start with the 20G. So it's going to be 20G, and the distance to C is going to be 2 meters, which is the distance from A to the midpoint, minus 1.6, so it's 0.4. This is supposed to equal, because we're still in equilibrium. If we're about to tilt, we're still in equilibrium. This is going to equal the 60G times my distance to C, which I just named over here as X. So G's can cancel, and from here I can find X as 20 times 0.4 divided 60. So my X is around 0.13 meters, or to be exact, it could be written as 2 over 15 meters. So if my distance is X is 2 over 15 meters, okay, then the question wants the greatest distance he can walk from P. So I can do something. I can erase all of this. I know now that my distance from the point P, or the new point, which is here, is basically 2 over 15. And I know that my P was 3 meters from the was 3 meters from A. So and C was 1.6 meters from A. So I can say that from C to P it was 3 meters minus 1.6, which is 1.4 meters. So the total distance between the new point where the boy is going to stand and the previous point, which is P, which is basically the distance he walked, is basically 1.4 plus 2 over 15. So 1.4 plus 2 over 15, that is going to give me an answer of 1.53 meters, and this is the distance he will move, and the greatest distance that he can walk from P without the beam tilting. If he moves more than this, then this weight over here component is going to have a moment greater than the opposing moments, and the beam is going to start tilting this way, and we're no longer going to be in equilibrium. I hope that this was helpful. I hope if you have any questions or suggestions to comment them down below. Please send me any past paper questions or topics you would like me to go through. Don't forget to like and subscribe, and thank you for watching. Have a good day.